This video is on the objective determine the critical value or values, if it's a two-tailed test, for a hypothesis test for the difference between two means. And this is where the population standard deviations are known. So, sigma 1 and sigma 2 are known. And that means that, your test statistic is going to be a z-score. You're going to be working with normal distributions instead of the student's t-distribution with so many degrees of freedom. And once you determine those critical values, that helps you define a rejection region or rejection regions. All right, so let's take a look at the question. So again, if you're unfamiliar with the topic, want to see more about it, click on more instruction. Look at their videos, their notes, their examples. Hopefully those all help you. Alright, so here Austin Clemens is writing a report about the city's climate for his high school environmental science class. To impress his teacher, Austin would like to show evidence that the population mean daily low temperature was lower during the 5-year period from 1998 to 2002 than it was for the 5-year period from 2013 to 2017. His researches claim he researches the claim using a website that records all the weather data observed at a local airport. After conducting the research, Austin assumes that the population standard deviations are 10.48 degrees Fahrenheit for that 5-year period from 98 to 2002 and 11.29 degrees Fahrenheit for that 5-year period from 2013 to 2017. Alright, so there's your sigma 1 and sigma 2. The population standard deviations are known. Alright, so due to the large amount of data in each 5-year period, Austin randomly selects the daily low temperatures for each group. The results are shown in the table below, right? So for that 5-year period from 98 to 2002, he selected 59 days at random, 59 daily low temperatures at random, and the average of those 59 daily low temperatures was 44.31 degrees Fahrenheit. And then for that 5-year period from 2013 to 2017, he selected at random 63 daily low temperatures, and their average was 46.02 degrees Fahrenheit. Let mu1 be the population mean daily low temperature during the 98 to 2002 period, and mu2 be the population mean daily low temperature during the 2013 to 2017 period. All right, the first question is, what type of test is this hypothesis test? Now they mean, is it a two-tailed test, a right-tailed test, or a left-tailed test? So that all depends on how the hypotheses are set up. All right, so that's what I'll do on some paper here. So remember, every hypothesis test starts with some sort of claim being tested or some sort of belief, attribute, whatever being tested. And this Austin person says he would like to show evidence that the population mean daily low temperature during 98 to 2002, that was mu1, the average temperature, the average daily low temperature for the 98 to 2002, that was mu1. Show that that population mean daily low temperature was lower during this period than it was during the 2013 to 2017 period. That would be mu2. So again, the average daily low temperature from 98 to 2002 is lower than the average daily low temperature from 2013 to 2017. Mu1 is less than mu2. Or subtract, looking at the difference between means here, mu1 minus mu2 is less than 0. Alright, so then once a claim is established, you can set up your hypotheses. The null hypothesis, the alternative hypothesis. Now this claim does not involve equality, so it's going to be represented by the alternative hypothesis. And then from the way the alternative hypothesis looks, you can say what kind of a test you're running. This is the parameter, is less than 0, less than a value. So this is a left-tailed test. All right, this is a left-tailed test. And being that it's a left-tailed test, when we go to find critical values, there's only going to be one critical value, right? And the rejection region will be a left tail. If it was greater than 0, then it would be a right-tailed test, and the rejection region would be a right tail. And if it is not equal to 0, it would be a two-tailed test, and you'd have half the rejection region in a left tail and half the rejection region in a right tail. And then the null hypothesis would be that mu1 minus mu2 is greater than or equal to 0, or the opposite of being less than 0. But, again, most times you're going to see them just using the equal sign. We're going to be assuming, the equality part, that mu1 minus mu2 equals 0. In other words, we're going to assume that the average daily low temperatures from 98 to 2002 is not different, is exactly the same as the average daily low temperatures from 2013 to 2017. Right? And then see if we want to keep this statement or not later. Do you reject this or not reject this later? But the first part was just asking, is it left-tailed, right-tailed, or two-tailed? And I'm seeing here from the setup of the hypotheses that it is a left-tailed test. All right, this fourth statement here. Okay. Now I'm sure there's more to it because the name of the objective is determining the critical values. All right. So then, okay, now now it's only a left-tailed test, so there's only one critical value. What is the critical value of the z-test statistic for the hypothesis test? And again, now they're giving us a significance level here, 10%. And they're asking us to use this this table. All right, so remember we're dealing with now alpha. Right, the significance level is 10%. Now normally we would find a test statistic, but we're not asked to do that here. Okay. Remember it's some z-score, and I'm not going to write the formula up here, but then we would find a rejection region. Right? Look for critical values in a rejection region. So remember, in this case, since sigma 1 and sigma 2 are known, right, the population standard deviations are known, the distribution for the difference of these two sample means, if you have samples, would be a normal distribution, and we would convert that to a standard normal, right? We'd convert everything to z-scores. And the z distribution, the standard normal, looked like this, right? It was a symmetrical bell-shaped curve, and the z-score underneath the peak was a z-score of 0. And what we are looking for, this is a left-tailed test. We're looking for a value. All right, I'll question marks here. We're looking for what z-score has an area to the left of 10%. Right? Remember alpha, the significance level, gives you the area of the rejection regions. So I want the area of this left tail to be 10%, and again, this would be our rejection region, right? And if the test statistic, right, if the z-score for our test statistic came in over here, we'd reject the null hypothesis, and if it doesn't, we would fail to reject it. Now, the notation for this z-score would be, now normally we'd go what z-score has 10% above it, that z with a subscript of 0.1. This is the z-score with 10% above it. So then we're just, we're doing the opposite of that. So this is the value we're looking for. We're looking for the opposite of that z-score with 10% above it. Now in the table they gave us, right, the z-score that has 10% above it is 1.282. All right, so back on my paper, this value is negative 1.282, right? The critical value for our left tail rejection region is negative 1.282. All right? So make sure you're putting in a negative here because, again, it is a left-tailed test. Now, if it were just a right-tailed test, it'd be positive 1.282, the entrance to that rejection region on the right tail. But it's a left-tailed test, so make sure it's negative. Okay, wonderful. All right, actually, I'll put up, this was my first video on this. I'll put up another one. I accidentally did some problem already here earlier, going over it with somebody else, so that's why it's completed in my preview. I'll do another one where I come back and do a second video on this objective, after this. So, but again, hopefully this all sounds familiar. I mean, this should all be familiar. We've done hypothesis tests now in previous assignments where you had to find critical values, critical z scores, critical t scores, but here we're back to z scores again. Okay. So hopefully watching me draw that out, maybe looking at more instruction when you need to, or and reading the answer explanations when they come up. Hopefully all this stuff helps you out when you go about doing this material on your own. And thank you very much for watching.